Hello and welcome. My name is Jessica Cruz, and today we will be doing Lab 1 charge tapes. Alright, let's get started. Introduction. This lab will demonstrate how much excess charge is in one piece of clear tape after two charged pieces of tape interact with each other. Some of the fundamental principles are listed below, which is Coulomb's law, Newton's second law, force due to gravity, and electric field. Some of the equations are shown to the right, where K is a constant, and Q1 is point charge 1, Q2 is point charge 2, and R is the distance between both charges. We use Newton's second law to set the electric force equal to the gravitational force, to then be able to solve the charge on one single tape and set it equal to the force of gravity. Results. After completing this lab, I found that the clear tape have the following charges. It has a point charge of 1.40071 E to the negative 8 coulombs and a line charge of 5.36146 E to negative 4 coulombs. And it has a deficiency of electrons of 8.6 E to the 10. Systems and surroundings. The system is the tape, flat surface, and books. The surrounding is everything else around it. Assumptions. I assume that air resistance is negligible in this experiment. That both pieces of tape have the same net charge and that the point charge is at the center of the tape. Initial conditions. To start this experiment, we needed clear tape, a ruler, a flat surface, and stackable items, and I used books. Procedure. Place one tape on a flat surface, this would be our base tape, and then place another tape on top of the base tape, which is our U tape. Now, we pull one end of the U tape quickly off the base tape and observe our interactions. After that, we're going to grab a plastic pin and rub it into our hair and place it near the U tape and observe its interactions again. We're going to repeat number 1, but this time place a U tape on a stackable object. And we're going to place another U tape below the suspended U tape and observe its interactions, and we will measure the distance. Experiment. Tape length. Its length was 0.20 meters, the mass was 0.0002 kilograms, the distance was 0.03 meters, and the magnitude of gravitational force was 1.96 E to the negative 3 newtons, and the magnitude of the electric charge was 1.4 E to the negative 8 coulombs. Glow script point charge. So this was my first computational model. And in this code, I named the constants, did some calculations, and then created the arrows. The orange arrow represents the electrical force, and the green arrow represents the gravitational force. This is my second computational model where we see the line charge. This code was a bit long, so I only put a little mini screenshot of what I have, and I put a link so you could see my actual code in there. And here we could see how now it shows a line of charges compared to our first one, which was just point charge. Coding questions. So the magnitude of the charge of one piece of tape for my first computational model was 1.4 E to the negative 8 coulombs. The magnitude of the charge by my second computational model was 5.36 E negative 4 coulombs. An assumption I made was to ignore air resistance, and I had to assume or treat the tape as if there was a point charge. Additional questions. What if electrons are negatively charged and protons are positively charged? What if the signs of the charge were reversed, meaning if electrons were positive and protons were negative, what would the charge about the observations you made with your tapes and other charged objects? If this were to happen, my tape and other charged objects would not change. This is because like charges repel and opposite charges attract. For the second question, I said that both models are different because one model is for a point charge and the other one is for a line charge. I believe the line charge is more accurate because it takes into consideration the tape's length, which will give us a closer real value. Thank you.